Ever looked up at the sky and wished you could make it rain? What if I told you we can? From the deserts of UAE to the farmlands of India, for decades, scientists have been pulling off a feat that sounds like something out of a sci-fi movie, and it's changing how we think about water, droughts, and even air pollution. Right here, right now. It's not magic, it's how we hack the sky.
You are watching Intrigue Inc.
This is Vincent Schaefer speaking. I would like to take you into the laboratory and show you a few of the experiments that led us to our outdoor experiments in converting clouds into snow. Using a home freezing unit such as this, which has a temperature of around 0 Fahrenheit, we can form supercool clouds just like those in the natural atmosphere by breathing into the box. The moist air from the breath condenses and forms a cloud.
Back in 1946, at General Electric, scientists Vincent Schaefer, Bernard Van Goot, and Irving Langmuir were actually researching aircraft icing. But what they stumbled upon was far more significant. They found that by introducing tiny particles into lab-made clouds, they could create ice. Think about it for a second. They could make it snow indoors. Van Goot later redefined this, identifying silver iodide as an even more effective agent. This wasn't just interesting, it was a game changer. A year later, Project Cyrus took flight. A B-17 bomber rode through the skies, dispersing dry ice into the clouds. The result? A clear racetrack formed in the cloud deck, proving that human intervention could undeniably alter cloud physics. This wasn't about creating clouds from nothing, but optimizing what nature already provided. Okay, so before we dive deeper into how we seed clouds, let's quickly break down how they form naturally. Clouds are essentially billions of tiny water droplets, or ice crystals. They form when invisible water vapor in the atmosphere cools and condenses as air rises. Simple enough, right? But here's the kicker. Nature isn't always efficient. Studies show that a whopping 80% of cloud droplets may never actually reach the ground as rain or snow naturally. Think of all that untapped potential. Clouds come in 3 main types: all liquid, ice crystal, and mixed phase. It's these mixed phase clouds, containing both liquid water and ice crystals at temperatures between 14 degrees and minus 31 degrees Fahrenheit, that are prime targets for cloud seeding. It's about giving nature a nudge, coaxing out the water that's already there, but just needs a little help to fall.
It was an American scientist, Bernie Vonnegut, who first suggested that silver iodide be used instead of dry ice, and perhaps much less of it would be needed. Sometimes there are enough of these nuclei present, and the clouds rain of their own accord. If there are not enough natural nuclei present in the atmosphere, it is possible to seed the clouds with artificial nuclei. So far, silver iodide crystals have proved to be the most effective and convenient artificial ice nuclei.
When it comes to making a chain, one of our best tools is silver iodide. Think of it as a tiny, invisible ice maker for the clouds. When we introduce silver iodide into the clouds, they act as artificial nuclei for water molecules. They are special because their crystal structure is almost identical to natural ice. When we release silver iodide into a cloud, these particles go to work. The water droplets in the cloud instantly freeze onto it. It's like a secret signal telling them to turn into ice. more and more water vapor sticks to them, making them heavy. And what happens when things get heavy in the sky? They fall. As these ice particles tumble down, they either melt into raindrops or stay frozen as snow. We are not creating new water, by the way. We are just helping the clouds unleash the water they already have. Silver iodide is a key player in making it rain, when and where we need it the most. So, how do we get these tiny particles into the massive clouds? We have a few sophisticated ways to do it. The most common is aircraft-based seeding. Modified planes with wind-mounted flares or onboard dispensers fly directly into or above the target clouds, releasing seeding agents. This gives us incredible precision. But what if the planes are not an option? That's where ground-based generators come in. These release seeding materials from the ground, relying on natural updraft and favorable winds to carry the agents up into the clouds. Many can even operate remotely, which is super efficient. And for those hard-to-reach, high-altitude clouds, we sometimes use rocket-delivered seeding. Small rockets send the agents directly into the cloud formation. Each method has its advantage, but they all share the same goal: getting those vital particles to where they can work their magic. So, does it actually work? The general consensus is yes, it does, with moderate effectiveness. As for the report shared by the Department of Public Works in the County of Los Angeles, cloud seeding can increase precipitation by 10 to 15%. Another report shared by MDPI showcases that cloud seeding can increase precipitation by 10 to 30%. This isn't just a science experiment. It has profound real-world benefits. Cloud seeding is a powerful tool for drought mitigation. This directly helps agriculture, leading to better crop yields, especially in places like India, which heavily rely on monsoon season. It can also aid in wildfire control by increasing moisture levels and reducing fire risk. More rain also means more water for hydroelectric power, contributing to energy security. Also, fighting increasing air pollution and improving air quality. In super polluted cities like Delhi in India, trials are being planned for August 2025 to use cloud seeding to trigger artificial rain and literally wash pollutants out of the air. Imagine that, fighting smog with a sprinkle. The USA, China, UAE, and Australia are already heavily invested into this technology. Cloud seeding isn't a silver bullet for climate change, but it's a vital part of the toolkit. It's a testament for human ingenuity, a way to optimize natural processes and address pressing challenges like water scarcity and pollution. As our planet faces increasing demands, understanding and wisely managing our atmosphere becomes crucial. The future of our water security, climate adaptation, and even global stability might just depend on how smartly we continue to engineer the clouds above us. What do you think about cloud seeding? Let us know in the comments below. And don't forget to like this video and subscribe for more deep dives into the technology shaping our world.